Hello, in this video, we will build a simple real-time chat app. We use Dioxus as a front-end client, Axum as back-end server. So in this video, we will learn how to implement a WebSocket in Axum backend server, and also learn how to connect to WebSocket server in Dioxus front-end client. First, let me show you the demo for this chat application. So we open two web browsers. First, we will say an input field and a button. To join the chat, we need to enter a name. So let's enter a name, Jim. Then we can click the button to join the chat. It will go to the chat page. Also, in this web browser, let's enter a name, Kevin. Then let's join the chat. And in this input field, we can type a message. So let's type a message, hello. Then let's click this send button to send this message. After we send this message will simultaneously show in both web browsers. And let's also send a message in this browser. Hey. This message contains username and the message content. And if the message sent by current user, the background color will be blue. And the message sent by other users, the background color is green. Let's start build our project. In desktop, let's create a new folder. Let's give it a name, chat app. In terminal, let's type cd. Then let's drag this folder into the terminal. Let's press enter. We will change the current directory to this chat app. So in this chat app folder, let's first generate a Rust project. So cargo new. Let's give it a name server. Then let's also generate a Dioxus project. dx new. Let's give it a name client. We will choose bare bones. For stack, we will choose false. We will not use router, so we will choose false. We will not use Taiwan CSS, so we will choose false. And by default, we will choose web. Then we can close this terminal. Let's open this folder. You can see it will generate two folders. One is client for Dioxus, one is server for Axum backend server. Let's close this. Let's drag this chat app folder to Visual Studio Code. We will build our application from backend server. So first, let's go to this server folder. Let's go to cargo.toml file. We will add some dependencies. We will add a Tokyo for synchronous runtime and Axum for backend server. We add a futures WS for WebSocket and futures UTL. We add these dependencies so we can split WebSocket to sender and receiver. And we use Tower HTTP for cars, so we add a futures cars. Then let's go to src folder, main.rs file. First, let's open a new terminal in Visual Studio Code. Then let's add an attribute for main function, Tokyo main. So we can turn this main function as a sync function. So let's add a sync keyword before this main function. Let's create a function. Let's give it a name app. Let's add a parameter to this function. Let's give it a name tx. Type will be sender, import from Tokyo sync broadcast sender. In sender, let's give it a type of string. So this sender will send a string value. Later, we will put this sender tx in shared state in Axum server. Let's add a return type router for this function. So this router import from Axum. In this function, let's first create a variable, give it a name cost layer equal to, we will call cost layer, import from tower HTTP cost layer to create a new cost layer. Let's call method allow methods. Let's give it a argument any. This any import from tower HTTP, so it will allow any method. Then let's call allow origin method to allow origin, which will be the origin front-end client server item. It will be http://127.0.0.1 port 8080. Then we need to call parse method to convert it to header value. So we use turbofish to add a type header value import from Axum HTTP. This parse method will return a result, so let's call a wrapper to handle the result. Then let's create a new router and also return that router from this app function. So router new, let's add a router to this router. We will call route method on this router. Let's give it a pass slash. Let's give it a method get. Let's pass the sync closure as a handler. Let's just return a string value home. Let's add another router. We will use this router to implement a WebSocket. So this router will be chat router. We'll give it a pass slash chat. Its method also will be get. So when user send a request to this router, it will upgrade this get method to WebSocket. Then let's pass a handler chat handler. Later we will define this chat handler. Then let's call with state method to share this tx as shared state. So we'll pass this tx as argument. Last, let's call layer to add this course layer to this router. So we'll pass this course layer as argument. Let's define this chat handler. So it will be a sync function. Name is chat handler. We will add two parameters. First parameter is shared state, so we can get this tx standard. Let's give it a name state. In state, we give it a name tx. Type will be state. In state will be type standard string. Second parameter, let's give it a name ws. Then type will be WebSocket upgrade. Returning type will give it a IMPL into response. In this handler, we will call ws.onUpgrade method. We will pass a closure as argument. This closure can capture WebSocket. So let's create a parameter, give the name WebSocket. In its closure, we will call a function. So let's call the function handle WebSocket. Later, we will define this function. And this function will take two arguments. First is this shared state standard tx. So let's pass this tx as the first argument. And the second is this WebSocket we get from this callback closure. So let's pass this WebSocket as the second argument. Let's define this handle WebSocket function. It will be a sync function. Handle WebSocket. Let's add two parameters. First, let's give the name tx. Type will be standard string. Second one will be WebSocket. Type will be WebSocket. Import from Axum extractor ws WebSocket. We will not add a return type for this. In this function, let's first get the sender and the receiver from this WebSocket. So let's create a tuple. In this tuple, let's add a first element, give the name sender. Second element, let's give it a name receiver equal to WebSocket. So we can call split method on this WebSocket to get the sender and the receiver from this WebSocket. To call this split method, we need to import from future UTL. And this sender and receiver, we need to add a mute keyword to make this two mutable. Then let's get a receiver from this sender tx. Let's create a variable given the name x equal to tx that we will call subscriber method on this tx. So we can get a receiver from this tx. We share same sender tx in Axum server. So when we call this subscriber method, it will get a receiver from same sender, so all the receiver can receive message from this sender tx. Also, we need to make this receiver rx to be mutable, so let's add a mute keyword. Let's spawn a new Tokyo test to receive message from this rx receiver on background. So Tokyo spawn function to spawn a new Tokyo task. We'll pass a async block into this spawn function as argument. So async, let's add a move keyword to move the ownership to this block. After this spawn function, let's add a semicolon. In this async block, let's create a while let loop. So we will continually receive message from this Rx receiver. Also, we will destructure the inner value in OK. So OK is OK. Let's create a variable msg equal to, then Rx we will call receive method on this receiver Rx. This receive method is a async method. So we will call await to handle the async future. And it will return a result. So we use while let to continually receive message from this receiver X. Also destructure the inner value in the result. After we receive message from this X receiver, let's also send this message through WebSocket to the front-end client. So we use this sender from this WebSocket. So sender the send, and we will send the item is message import from Axum extract ws message from to convert this msg to a message. So we'll pass this msg into this from as argument. Then we need to call await to handle the future and unwrap to handle the result. Then let's use while let loop to continually receive message from front-end client through its WebSocket. So after this Tokyo spawn, let's create a while let loop. Sum, in this sum, let's give it a variable name msg. Then we will call receiver we get from this WebSocket. We will call next method to get the message from this receiver. Its next method is a sync method. Then we need to call await to handle the future. It will return an option hold a result. So we use this while let to continually receive message. Also use this sum to destructure the inner value in the option. Then in this while let block, let's use if let to destructure the inner value in the result. So OK. It's OK. Let's create a variable. Let's give it a name message to shadow this variable msg equal to msg. So we will get the inner value in the result is a message. And this msg is message type. This message type is enum type. So let's use match to handle this enum value msg. Let's add our arm. We only want the content from this message, so this arm's pattern is message text. And in this text, it will get the message content. So let's create a variable content in this text. In this arm, after we get the content from this receive message, we will send this content through the channel. So we use this tx sender to send this content. So in this arm, we will call tx.send method. Then we will convert this content to string. So we'll pass the content.toString method. Then we will call unwrap to handle the result. Let's add another arm. This arm we will add a pattern is match-all pattern. In this arm, let's just return nothing. This while let loop will continually receive message from front end. After we receive message from front end, we use this tx to send the message through the channel. And in this TalkQ task, we will continually receive message from the channel. And because this tx is the same tx, and this receiver rx, we get from the same tx, so all the receiver rx can receive message from the channel. Let's go back to main function. So in this main function, let's first create a broadcaster channel. Let's create a tuple, and the first element in this tuple will be the sender tx. And the second element, we will not use the second element, so let's give it an underscore equal to, we will call broadcaster from TalkQ channel to create a broadcaster channel. So it will return a tuple, and this tuple will contain sender and receiver. Then we will pass a capacity as the argument. Let's give it a value 100. Then let's call app function we create here to get the router. So let's create a variable app equal to app. We'll pass this tx as argument. Then let's create a listener. Let a listener equal to, we will call TalkQ net TCP listener band function. Then we'll pass a address. This listener will listen on 0.0.0.0 port 3000. Then let's call await to handle the future and wrap to handle the result. Last, we will call Axum serve function to serve our application with this listener. So we will pass this listener as the first argument and app as the second argument. Then we need to call await to handle the future and unwrap to handle the result. So we just finished our backend server. Let's start our server in terminal. First, let's go to this server directory. We will type a cd server. Then we will run cargo run to start our backend server. Then let's go to work on front end. First, let's go to this cargo.toml file in this clan. Let's add some dependencies to our Dioxus project. We will use GlueNet to connect to WebSocket server, and we add features so we can split WebSocket to sender and receiver in front-end clan. Then let's go to src folder, main.rs file. Let's remove all the code in this main.rs file. First, we will import from Dioxus, so we use Dioxus prelude asterisk. Then let's create a main function. Let's create a root component app. Returning type will be element. Import from Dioxus. Let's add an attribute for this function, component. So this function will be function component. Then let's create another component. -home. Returning type will be element. Let's also add an attribute component for its home function. So its home function will be function component. In its home component, let's call rsx macro. Let's just add a content home. Then let's pass its home component in its root component app component. So rsx macro home. In main function, let's call launch function from Dioxus to launch its root component app. In terminal, first let's change directory to its clan folder. So cd clan. Let's start our Dioxus application dx serve polite form web. Let's open a web browser. Let's visit 127.0.0.1.880. So it will show the home in the web browser. Let's link main.css file to our project. So in app component, in RSX macro, we will call document style sheet href isize micro passes isize slash main.css. Let's go to main.css file. Let's remove all this. Let's add some CSS style. We add this CSS style just to make our chat app look a little bit prettier. In this video, we will not talk too much about CSS. Only this part. Later we will explain a little bit. I will leave source code link in description. You can check CSS code in source code. Then let's go back to main.rs file. Let's go to this home component. In home component, let's create a few mutable state. First, let's create a mutable state message list. We use this state to store the messages user send and receive. So let's call use signal hook to create a new state. Then we will return an empty vector as the initial value. Let's create another mutable state message content. We use this state to store the user input message content. Let's call use signal hook. Let's give it an initial value, an empty string new. Let's create another mutable state. Let's give it a name receiver WS. We use this state to store the receiver from WebSocket. Let's call use signal hook. Let's give it an initial value none. Let's create another mutable state. Let's give it a name. We use this state to store the user's name. Let's give it an initial value, an empty string. Let's create a last state. We use this state to check whether or not user input his name. Let's call use signal hook. Let's give it an initial value false. Then we will use coroutine hook to connect to WebSocket server and also send a message to WebSocket server. Let's create a variable, give it a name chat client equal to, then we will call use coroutine hook. We will pass a single closure as argument. And we will add a move keyword to move the ownership. And this closure can capture a value is receiver Rx. So let's create a parameter in this closure. Let's give it a name Rx. We will give it a type annotation unbounded receiver because we will send a string value. So in this, we will give it a type of string. Then closure body, we also will add a sync move. After this, use coroutine. Let's add a semicolon. In this async block, let's connect to the WebSocket server. Let's create a tuple. In this tuple, first will be the sender. Let's create a variable in this tuple sender. Second will be receiver equal to, we will call WebSocket import from GlueNet WebSocket futures WebSocket open function to connect to the WebSocket server. And this WebSocket server's address is because we will connect to WebSocket, so it will start with ws:// localhost 3000/chat. This path is the root in Axum server. This root. Then we will call unwrapper to handle the result. Then we can call split method to split this WebSocket to sender and receiver. To call this split method, we need an import from futures. Then later we will in this async block to send a message, so we need to make this sender to be mutable. Let's add a mute keyword before this sender. Then let's set this receiver we get from WebSocket to this receiver WS state. So receiver WS set, because this data initial value is option value, so we will put this receiver in sum. So in set method, we will put sum hold this receiver. Then let's create a while let loop to continue receive message from this Rx unbounded receiver. We also need to destructure the inner value in option. So after this while let sum, in this sum we create a variable msg, then equal to Rx the next method to get the message. Then we need to call await to handle the future. It will return an option. So we use while let to continue receive message from this unbounded receiver, also destructure the inner value in sum. After we get the message from this receiver, let's format a message. Let message equal to format first, we will pass the username we get from this name state. So name. Second, we will pass this message we get from this receiver Rx. This message we format will like this, like username is Jim, colon, and message content is hello. It will contain username and message content. Then let's send this message to the WebSocket server. We will use this sender from WebSocket. So sender the send. Then we need to convert this string value to message. So message import from GlueNet message text to convert this message string value to message type. Then we need to call await to handle the future and unwrap to handle the result. Last, after this unwrap, let's add a semicolon. Then let's use future hook to create another async block. Let underscore. This use future hook will return nothing, so we give the returning value underscore. Then we will call use future hook. We'll pass a async closure as argument, and we will add a move keyword to move the ownership to its closure. Then let's add a async move to control body. After this, use future, let's add a semicolon. First, we need to get a receiver from this receiver WS state. So let's use if let sum receiver equal to receiver WS. We will call take method on this receiver WS. Because this is option value, so when we call take method, if this receiver WS is the sum holder receiver, it will take that sum holder that receiver and return that sum, and use none to replace this sum in this state. Then we will create a while let loop to continually receive message from this receiver. To receive message from this receiver, we need to make this receiver to be mutable. So let's add a mute keyword before this receiver in this sum. Then let's create a while let loop. And let's also destructure the inner value in option. So sum holder message msg equal to receiver we will call next method to get the message from its receiver. Then we need to call await to handle the future. And this message MSG in sum is result value. So let's use if light to destructure the inner value in result. So if light OK, hold message MSG equal to MSG. This MSG value type is message. Message is a enum type, so let's use match to handle this MSG enum value. Let's add one arm is message text. So this arm in this text we can get the content from this MSG. Let's give it a name content. Then in this arm, let's push its content to this message list. So message list we'll call writer method to write a content to its message list. Then we will call push method to push its content to the vector in its message list. We will pass this content as the argument. Then let's add another arm. This arm's pattern will be material pattern underscore. In this arm, we will just return nothing. Here we got an error because we forgot to make this unbounded receiver to be mutable. So let's add a mute keyword before this Rx in its coroutine. We will get rid of that error. Then let's go to RSX macro. In RSX macro, let's create a if else block. If user didn't input his name, we want a user to input a name. So we will use this has name state. If user didn't have name, its value will be false. Let's add an exclamation marker. It means user didn't input his name. Then we want a user to input his name. So let's add a div element. Let's add a class. Let's give it a class chat container. This chat container will just center the item in it and also have a height and a background color. In its div element, let's add another div element. Let's also give it a class chat and another class input name. This chat we will give it a width and height, background color, and position, relative, border radius, and shadow. This input name will overwrite height, give it a height 5%. In its div element, let's add input element. Let's give it a type text. Let's give it a value name. Let's add on input event. We will set the value we get from this input field to this name state. So name set event e value to get the value from this input field. Then let's create a button. In this button, let's add on click event. And when we click this button, we will set the has name state to true. And let's add a disabled attribute. If user input name trim equal to empty string, then we will give it a value true. So if the user input an empty string, this button will be disabled. Then let's add a content to this button, John chat. Let's add a placeholder attribute for this input field. Placeholder. Let's give it a value. Enter your name. Let's go to the web browser. The input field and the button will like this. And we add a class for this input field and the button in its main.css file. After this, if blocker. Here, let's add a else blocker. So this else means user already input a username. So this blocker will render the chat page. Let's create a div element. Let's give it a class chat container. In this div element, let's add another div element. Let's give it a class chat. This time we will not add input name, so its head from this chat class will not be overwritten. In this div element, let's add another div element. Let's add a class. We will give it a class message container. We add this message container, give it a padding and width, height, overflow auto, and display flex, and we reverse flex direction. Later we will see how this CSS works. In this div element, let's render each message from this message list. So we will add a pair of curly brackets. So in this pair of curly brackets, we can write a Rust code message list. Then we will call iter method to create an iterator from the vector in this message list. Then we will call reverse method to reverse the order of each item in this iterator. Then let's call map method to map each message in this message list. We'll pass a closure. This closure can capture each message. Let's give it a name item. In this closure body, let's first get the username from each message. When we send the message, we format this message with username, and we separate username with message content by this colon. So let's create a variable username equal to item that we will call split method. Split this message item by colon. Then let's call collect method to convert it to a vector. Hold a string slice value. In this vector, first element will be the username, so let's use index number 0 to get the username. Then we will return RxX macro in its map method. In its RxX macro, we will create a p element. Let's add a class. Let's give it a class message item. This message item will have a font size, background color, and color, border radius, padding, and margin bottle. Let's add another class. This class we will create a conditional class. So if this username from the message item equal to the name state, its name state is a value from the user input. Then we will give it a class user message. This user message we will just overwrite the background color to blue. Then let's render each message item in its p element. So item after this div element, but in this div element. So in this chat div element, let's create another div element. Let's give it a class input container. This input container will have a position absolute, so we will put this input container at the bottle. We give it a bottle 0. It will have a width and height. Then in its div element, let's create an input element. Let's add a type. Give it a text. Value will be message content. Placeholder Let's show the username in its placeholder. So name. Then let's add on input event. We will set the value from this input to the message content data. So message content set event e value. Then in its div element, after this input element, let's create a button element. Let's add on click event. In its on click event, so when we click this button, we will send this message to coroutine. So we will call chat client. This chat client is from this coroutine. We will send the message content into the coroutine. After we send the value, we will reset the message content's value to empty string. So message content set string new. Then let's add a disabled attribute for this button. So if message content trim equal to empty string, we will return value true. So this button will be disabled. Then let's add a content to this button. Send. Here, after this trim, let's add a pair of parentheses. So when we click this button, this will use this chat client to send this message content to coroutine. And in this coroutine, this unbounded receiver X will receive message from this chat client. When it receives message from this X, it will send this message through WebSocket to the WebSocket server. Then, in WebSocket server, when we receive message from client, and we will send this message through this channel, this receiver X will receive message from the channel. After it receives message, it will send this message back to the front end. Use this sender from WebSocket. So in this use feature, we will receive message from this receiver of WebSocket. After we receive message, then we will push this message to message list. Because this receiver X in backend server or from this sender TX, so all the user can receive the message. So in front end, when user send the message, it also will receive the message he sent. We just finished our project, so let's go to the web browser. We will open two web browsers. So in first web browser, let's enter a username. Let's give the name Jim. It will go to the chat page. In second browser, let's give it a username Kevin. So in its input field, it will show the current username. Let's send a message from the first browser. Hello. So you can see it will show the message in both browser. Let's send a message in second browser. Hey. This message container class, if we remove this display flex and flex direction, you can see the message will start from top. So when we add this to style, the message will start from bottom. In its message list, if we remove this reverse method on this message list, let's join the chat. Jim and Kevin. Let's send a message. Hello. Let's send a message. Hey. When we send a new message, the new message will at the top of the old message. We want the new message below the old message. So we need to add a reverse method on this message list to reverse the order. So let's send a message, hello. And let's send a message. OK. So you can see the message will start from bottom and the new message will below the old message. This is how we build a real-time chat app by using Dioxus and Axum with WebSocket. If you like this video, please give me a thumb up and subscribe my channel. Hope to see you next time.